Hello viewers, in this video I'm going to show the solution to question 13 from a 2021 paper 1 at grade 12 internal. So the question reads, the points A, B, C and D are on the circumference of a circle center O such that angle AOC is equal to 126 degrees. So angle at the center there is 126. AO is parallel to DC. So AO is parallel to DC. And angle OCB is equal to 33 degrees. Find ADC, which is this angle here, B, OCD, which is this angle there, and then the last part is BAO, which is that angle over there. So we'll start with the first part. To work out the first part, where we find ADC. So ADC is the angle which is positioned here. And to work out this part of the question, we're going to use two theorems. The first theorem is about angle which is here at the center in relation to the angle at the circumference. Then I'll also come up with a relationship between angle B and angle D. So if you've noticed, this is a four-sided polygon. So the 4 points of this four-sided polygons are touching the circle. So it means that this four-sided polygon is a cyclic quadrilateral. So there's a relationship between angle B and also angle D. So we go straight to finding angle ABC. So angle ABC, angle ABC is related to the angle at the center AOC. So now the relation is coming about because this angle at the center and this angle at the circumference, they share the same arc, or they are all opposite to this same arc. So which gives the relation angle at the center is twice angle at the circumference. So to find ABC, we just say ABC is half of angle at the center. So this means ABC is equal to angle AOC over 2. Now, what is angle AOC? Angle AOC is given as 126 degrees. So divide this by 2 gives angle ABC. When we divide by 2, 2 into 2, 1, 2 into 12, that's a 6, and 2 into 6, that's a 3 here. So this gives a 63 degrees. So this means that angle ABC is 63 degrees. And the principle we just used is angle at the center is 2 times angle at the circumference. Okay, so now we go to the relationship between D and B. So angle B and angle D are related. As I said, this here is a cyclic quadrilateral because all the 4 points of this shape are touching the circle. So the relationship is that angle ADC, if added to angle ABC, these two angles add up to 180 degrees. And the concept here is opposite angles of a cyclic quadrilateral add up to 180 degrees. So these two angles are adding up to 180 degrees. So to find angle ADC, we just substitute since we got angle ABC at 63, so we put 63 degrees here and equal to 180 degrees, and then take 63 to the right side, which gives ADC equal to 180 degrees, take away 63 degrees, and the subtraction gives us ADC is equal to, if we subtract here 180 degrees, take away 63, there we get a 1 from 8, here we remain with a 7, this is 10, 10 take away 3, 7, 7 take away 6, that's a 1, and here 1 take away 0, 1, so we're getting 117 degrees. So our answer here is 117 degrees. So that is angle ADC. Let's now go to the second part, which is part B, where we're going to find angle OCD. So for angle OCD, we're going to use a principle on angles associated with straight lines. Angles associated with straight lines. So since AO is parallel to DC, AO is parallel to DC, then it means that these angles here, the angle AOC and the angle OCD, are related. And the relationship that is just there is that these angles are allied angles. Angle AOC and angle OCD are allied angles. So allied angles add up to 180. Allied angles add up to 180. So we can show the relationship. So angle AOC, if added to angle OCD, these two angles add up to 180, all because they are allied angles. And allied angles add up to 180 degrees. So that's just the concept here. So now we have we've been given angle AOC, which is 126. So if angle AOC is 126 degrees, then we can calculate angle OCD. So angle OCD will just take 126 to the right side. So OCD is equal to 180 degrees, take away 126 degrees. OCD, angle OCD is equal to, if we subtract 180 minus 126, 180 degrees minus 126 degrees. First of all, we get a 1 from 8, so here we remain with a 7. This is 10. 10 take away 6, that's 4. 7 take away 2, that's a 5. 1 take away 1, that's 0, so 54. So angle OCD is 54 degrees. So allied angles, angles that are associated with a straight line. So if this is parallel to this one, then if you draw a transversal, it means that this angle here is related to this angle here, which gives a 180 if you add them. And for that, we just subtract 180, take away 126 to get this one. So far, we have solved for three angles. So we know that here this angle is 54 degrees. This angle here is 63 degrees. This angle at D is 117. So if we have these three angles, then now let's go to the last part of this question, which is finding angle BAO. So to work out C, I'm just going to use the concept opposite angles in a cyclic quadrilateral add up to 180. Opposite angles in a cyclic quadrilateral add up to 180. So, part C, we want angle BAO. So, to find angle BAO, first of all, we're going to use the principle on a cyclic quadrilateral. So, meaning that this angle here is opposite to this angle which is at C. So angle at A is opposite to the angle at C, and these two angles add up to 180. So I'm going to start with that concept. So angle BAD, the whole lot of angle BAD here, BAD plus angle BCD, which is everything here, BCD, all this adds up to 180. So this is because angles in a cyclic quadrilateral, opposite angles in a cyclic quadrilateral add up to 180 degrees. So this is the theorem we're working with. So if angle BAD and angle BCD are adding up to 180, then it means that we can get the full measure, which is here, since we have the full measure here. So BCD, let's work out BCD. BCD, what angle is BCD? BCD is made up of angle BCO and angle OCD, the one we just calculated. So this is 33 plus 54. What is 33 plus 54? So 33 plus 54 gives 3 plus 4, that's a 7. 3 plus 5, that's 8. So it gives 87. So this measure here at C is 87. So this means we can calculate the measure at BAD, which is this measure here. So we're going to say BAD plus, on BCD, we're going to put what we just calculated here, which is 87 degrees, equal to 180 degrees. So BAD is equal to 180 degrees, take away 87. BAD gives 93. If we calculate 180 degrees minus 87, we get a 1 from 8, so 7. We put a 1 there on 0, that's a 10. 10 take away 7, that's 3. 17 take away 8, that's 9. So we get 93 degrees. So for BAD, we're getting 93 degrees. But then we already know that there is a relationship between angle ADC and angle DAO or OAD. So these two angles here are related, and the relationship is coming from parallel lines. Since these two lines are parallel lines, then it means that this angle formed here and this angle formed here add up to 180. So these two also are allied angles. So this means that they add up to 180. So what is 180 take away 117? 180 take away 117 just gives a 63 degrees. So this means this angle at A, angle OAD, is 63 degrees. Now the full measure that we've come up with for BAD is 93. So the full measure is 93. So if this whole angle is 93, we'll just subtract 63 to get the measure that is supposed to be there. So, and this gives us BAO is equal to, so we're saying BAO is just subtracting BAD, which is the full measure, that we calculated, 93. So BAD subtract the measure which we've come up with here, allied angles, because of the relationship that exists between 117 and that one which is there, so which is angle OAD. If we subtract these two angles, we'll get angle BAO. Angle BAO is equal to BAD, 93 degrees, take away angle OAD. OAD is this angle, 63 degrees. So the measure gives us 30. So 93 degrees take away 63 degrees. 3 take away 3, that's a 0. 9 take away 6, that is 3. So 30 degrees. So this means that the angle BAO is 30 degrees. Okay, and that's it for this question. Thank you so much for watching this video.